All right, we're going to look at 7c, and we're converting an equation between rectangular form and polar form. So this video, we're going to be looking at an equation in rectangular form and converting it into polar form. So we have our formulas that we learned about in 7b. We know x is equal to r times cosine of theta, and y is equal to r times sine of theta. So if we are given an equation in rectangular form, we have x and y, and so we want to rewrite our equation and replace x and y using r cosine of theta and r sine of theta. Once we do that, we want to solve for r. So we have to get r by itself, and this may require us to use some of our Pythagorean identities. So in example 5, it says express the equation x squared equals 4y in polar coordinates. So the first thing that I'm going to do is I am going to substitute x out and replace it with r cosine of theta. So I have r cosine of theta inside parentheses because all of that is getting squared since x was getting squared. And that is equal to 4 times, and then I'm going to replace y with r sine of theta. Now I'm going to get rid of my parentheses. I know that both the r and the cosine are being squared, so I can rewrite this as r squared times cosine squared equals 4 times r times sine of theta. Now when I look at this, if I want to solve for r, I have to get all of my r's together, but I do have an r squared and an r. So what I'm going to do is divide both sides by r. I want to find a different color pen here. So we're going to divide this by r and divide this by r. So what's going to happen is my r's on the right are going to cancel. And then on the left, since I had r squared, I'm going to cancel out one of those with the 1 in my denominator, so I do have 1r left over. So I have r cosine squared equals 4 sine of theta. Well, now I have r just on the left, so I'm going to divide both sides by what's next to my r, since those are being multiplied. The inverse is to divide. So divide both sides by cosine squared. It'll cancel out on the left side, so I'm left with r by itself. And I have 4 times sine divided by cosine squared. And down here, I'm going to write it as 4 sine of theta over cosine times 1 over cosine. Forgot my thetas there. Because if I have 2 cosines, that's cosine squared, I can split it into one of each, and I put a multiplication sign in between. Because if I go backwards, cosine times cosine is cosine squared. So now, if I go up over here, I know that I still have my 4, my fingers there, and then sine over cosine is tangent, and then 1 over cosine is secant. So I got r by itself. I did simplify this into tangent and secant, so we are done. This is our equation in polar form when we were originally given rectangular form. So let's look at the example underneath, example 6. So I'm going to scoot this up. Again, we have our equation in rectangular form because we have an x and a y, and we are trying to change it into polar form. And so I'm going to replace my y with r times sine of theta, replace my x with r times cosine of theta. And I did put that negative out in front. And actually, since my x wasn't being squared, I don't really need those parentheses, but it's nice to just be careful. So I'm going to rewrite this without parentheses. Again, I want to get my r's together, and I can't add r's since the r is being connected with cosine on this side, but r is connected with sine. So I can't combine those since they have different trigs connected to them. So I'm still going to divide both sides by r. Now when I do that, my r's cancel on the left and on the right. And so if we look back up at the steps at the top that we had, we need to solve for r, but right now both r's disappeared. So let's make a note on the side. When your r's disappear, we are going to solve for theta. So I actually want to add that up here as well in our steps. So if r's disappear, solve for theta. So I'm going to go back to example 6 and pick up where we left off. I have sine of theta equals negative cosine of theta. And I am going to divide both sides by cosine of theta, because I know that if I have sine divided by cosine, that will turn into tangent. So that's why I'm dividing both sides by cosine. My cosines will cancel out on the right-hand side, and I'm just left with negative, which there is an invisible -1 there. So I'm going to go up over here. I have sine over cosine equals -1. Well, like I just said, sine over cosine is tangent. So I have tangent of theta equals -1. If I want to get theta by itself, I have to get rid of tangent. So I'm going to take the arctangent of both the left and the right. So arctangent and tangent will cancel. I get theta equals arctangent of -1. And then using our unit circle, well, I don't have one that I can show on camera, but we're looking for what angles have a tangent value of -1, and it looks like it's 3 pi over 4, or we could say theta equals 7 pi over 4. We also know there's other coterminal angles that work, but this is where we're going to leave our answer for the equation if we convert the rectangular equation into a polar form equation.